Today in our physics unit and measurement, now to see one numerical based on uses of dimension analysis. What is dimension analysis? The method of obtaining the solution of problem by making use of dimension formula is called dimension analysis. There are three uses of dimension analysis. First, to obtain the unit of any physical quantity into two different system of units. Second, to check the dimension correctness, and third is to obtain the equation. It's to obtain the physical equation showing its relation with the other physical quantity. Now you can use here the third usage, that is obtain the physical equation showing its relation with other physical quantity. The numerical is like this way, just you can see here. The time period of the simple pendulum T depends on its mass, its length and time. Obtain the equation of time period using dimension analysis. Now you know that here, suppose this is a simple pendulum. This is simple pendulum and length of the pendulum is L and mass is m and acceleration due to gravity acting downward direction, that is g. Now you know that here T proportional to m raised to a, proportional to L raised to b and proportional to g raised to c. Therefore T proportional to m raised to a, L raised to b and g raised to c. Therefore T is equal to k m raised to a, L raised to b and g raised to c, where k non-zero constant and a, b, c belongs to R. Now writing the dimension formula on both the sides, writing the dimensional formula on both sides. Therefore m0 L0 T1 is equal to k is dimensionless, we can write here m1 raised to a, L1 raised to b and g, that is L1 T minus 2 raised to c. Now rearranging the terms here, so you can get here m0 L0 T1 is equal to m raised to a, L raised to b and L raised to c and T raised to minus 2c. Therefore is equal to m raised to a, L raised to b plus c and T raised to minus 2c is equal, that is here m0 L0 T1. Now comparing the power on both the side, so comparing the power on both the side we get, so we have to compare here, so you can get here, that is a is equal to 0, then b plus c is equal to 0 and here that is 2c minus 2c is equal to 1, therefore c is equal to minus 1 half. Now keeping c is equal to 1 half in this equation, so you can get here, that is b is equal to minus c is equal to minus of minus 1 half is equal to 1 by 2. Now we can get here, that is b is equal to 1 half, a is equal to 0 and c is equal to minus 1 half. Keeping this value in equation number 1, our equation is T is equal to k m raised to a, L raised to b and g raised to c is equal to k m raised to 0, L raised to 1 half and g raised to minus 1 half is equal to k under root L upon g. Now experimentally the value of the k is pi by, experimentally k is equal to 2 pi, so we can get here t is equal to 2 pi under root L upon g. So this is the required equation. So this way to understand this numerical. In this numerical, the time period depends on, that is mass, length and acceleration due to gravity. Therefore T proportional to L raised, therefore T proportional to m raised to a, proportional to L raised to b and proportional to g raised to c. Therefore T is equal to k m raised to a, L raised to b and g raised to c, where k non-zero constant a, b, c belongs to R. Now writing the dimension formula on both the side and simplifying the terms, and finally we can comparing its power, then at the last we will get here, that is a is equal to 0, b is equal to 1 half, and c is equal to minus 1 half. Keeping this value in equation number 1, and finally we can get here t is equal to k under root L upon g. K is equal to 2 pi experimentally, therefore t is equal to 2 pi under root L upon g. So this way to understand this numerical. Thank you very much.